Everything you own is slowly falling apart. Your car, your body, this planet, the sun itself. Not because something is wrong with them, because something is right. And right means the universe is doing exactly what it's supposed to do. Here's the part that should unsettle you. Actually Science, Episode 5. Entropy, Why Everything Falls Apart. The misconception, what everyone gets wrong about entropy. Most people, if you ask them what entropy means, will say something like, things fall apart, disorder increases, chaos takes over, ice melts, rooms get messy, cars rust. That intuition isn't wrong, but it's incomplete in a way that changes everything. Entropy is not the tendency toward chaos, it's the tendency toward the most likely arrangement. And the most likely arrangement for almost any physical system is not special. It's not ordered, it's not arranged, it's just average. Here's the part. Most explanations miss. Disorder looks chaotic to us because we are order. We are an incredibly improbable local arrangement of matter. A living cell is a structure so statistically unlikely that if you shuffled its atoms randomly 1 trillion times, you would almost certainly never produce it again. Entropy doesn't hate you, it doesn't target order, it's completely indifferent. It's just that there are vastly more ways for things to be random than for them to be structured, so randomness keeps winning, every time, everywhere, without exception. The ground floor. What the second law of thermodynamics actually says. In 1850, a German physicist named Rudolf Clausius looked at steam engines and noticed something strange. You could always convert work into heat completely, but you could never convert heat into work completely. Some heat was always lost, always, no matter how good your engine was. He called this loss entropy from the Greek word for transformation. He defined it mathematically. And then he wrote the second law of thermodynamics. In any closed system, entropy does not decrease. Let's be precise about what this means. A closed system is one where no energy enters or leaves. Our universe is, as far as we can determine, a closed system, which means entropy in the universe does not decrease, total, ever. This is different from saying entropy always increases. It can stay flat. In a perfectly reversible process, entropy stays the same, but it cannot go down. The universe does not allow it. This one asymmetry, entropy increases forward in time but not backward, is the reason time has a direction at all. Without entropy, past and future would be mathematically identical. Here's the concrete version. Imagine you have a box with a divider. Left side, hot gas. Right side, cold gas. Remove the divider. The hot and cold molecules mix. The temperature equalizes. You can never unmix them. You can never get the hot gas back on the left and the cold gas back on the right, not without putting energy in from outside the box. That's entropy. The system moved from a less likely arrangement to a more likely one, and it can't go back. Now scale this up. Every chemical reaction in your body is using a tiny amount of energy to fight entropy locally. Your cells maintain their structure by constantly consuming energy. The moment that energy stops, death, decay, dissolution, entropy resumes. The atoms that were you scatter toward the average. You are not a thing, you are a process. A temporary energy-expensive process that entropy tolerates only as long as you keep paying. Why it matters. Life, death, and the end of the universe. Life is a local, temporary violation of entropy. This is not a metaphor. It is a thermodynamic description. The sun pours low-entropy energy, concentrated, ordered photons onto Earth. Plants capture this energy and use it to build structured molecules, sugars, proteins, cells. Animals eat those plants. We eat those animals. At every step, we're borrowing order from the sun's low entropy and paying it back as waste heat. The sun itself is burning through its hydrogen supply. In approximately 5 billion years, it will exhaust it. Without the sun's energy input, complex life on Earth cannot maintain its order. Entropy wins locally. Zoom further out. In the very long-term future, we're talking numbers so large they have no everyday analog. The last stars will burn out. Black holes will evaporate through Hawking radiation. The universe will reach a state called heat death, maximum entropy, uniform temperature, no energy gradients, no structure, no processes. Not a bang, not a freeze, just evenness, everywhere, forever. The frontier, what we still don't know. The second law of thermodynamics is one of the best-tested laws in all of physics. It has never been observed to be violated, not once, at any scale, in any experiment. But here is the honest part. We don't fully understand why it works the way it does at the quantum level. Individual quantum interactions are time reversible. Run the equations of quantum mechanics backward and they still describe valid physics. Yet somehow, at the macroscopic scale, time is not reversible. Entropy does not decrease. The arrow of time is real. How does a time-symmetric microscopic world produce a time-asymmetric macroscopic one? This is called the arrow of time problem, and it is genuinely unsolved. Physicists have proposals. None are fully satisfactory. The most honest answer to why time moves forward is because the universe started in an extremely low entropy state, the Big Bang, and has been moving toward higher entropy ever since. We don't fully know why the Big Bang started low. That question is still open. Actually science, at sign, actually science though, complex science, actually explained.